Hi, good people. We're going on to section 1.4.2 in differential equations, and there's something called integrating factors. And the integrating factor, well, we're going to use it to solve differential equations. So here's what we're going to do. Here's our original differential equation: y prime plus some function of x, p of x times y equals q of x. This is a standard way of writing a linear first order differential equation. And what we need to do is find some function I of x, so it's a function of x, such that the derivative of I winds up being I times p. And I'm talking about I'm referring to the p over there. So somehow, based on the p that we have here, I have to find a function I. I, of course, is my integrating. Get it? I stands for integrating factor. Get it? Such that the derivative of I winds up being ip. So first, I'm going to show you why finding such a thing will help. Then I'm going to show you how to find it. So first, why does it help? Well, what I'm going to do is I'm going to multiply the original differential equation by I of x, and I'm going to get this: iy prime plus ipy equals iq. iq is something we could all use, by the way. Well, if you notice, what I have over here, I'm going to put in parentheses now. I said parentheses, but I meant a little bracket thingy. If you notice that this expression here is the integral of iy. And that's because of the product rule. Because this is I times y prime. This is I prime. Remember, I prime is ip. That's how we defined this function. And that's beautiful. So now we have the iy prime equals iq, which means that all I got to do is integrate both sides. So I get iy equals the integral of iq. And this is, of course, I of x, q of x dx. I didn't bother writing that. And now I just have to divide both sides by I. And I have a solution to my differential equation. Y is equal to 1 over I times the integral of iq. Now, of course, I have to be able to find this I. And it would be nice if I could integrate iq. But even if I can't, at least we have technically a solution to the differential equation, because there's no more y primes here. Anyway, we just have y as some explicit function of x. By the way, I don't bother. I'm not going to, when I do, we'll see I'll just talk about it when we get to the problems. Anyway, how do you find I of x? So from this equation up here, I prime equals ip, which means the I dx equals ip. Remember, I is a function of x, p is a function of x. And this is a separable differential equation. So I'm going to rewrite this. I'm going to bring the I down there and the x up there. So I get di over I equals p dx. Now I integrate both sides. And I get, this becomes ln I. And this is just the integral of p dx. And that's all I could say at this point, because I don't know what the function p is. So we're just going to have to leave it like that. Hopefully we can integrate it, but we'll see. Anyway, I exponentiate both sides, so ln I equals this, so I is equal to e to the integral of p dx. So I is equal to e to the integral of p. Now this may not look like anything great, but it will be great, and we're going to be able to use it. We're going to use it to solve differential equations. So this is our first step, and in our next video, I'm going to show you two examples. In fact, I'm going to show you the same two examples that we did for variation parameters. Those same two examples that we solved with variation parameters, we're going to solve those same two examples now with integrating factors. So it'll be a different way of solving those differential equations, but we're going to get the same correct answer. See you soon.